Okay, let's kick off where we stopped. So I think everybody understands the concept of marginal revenue. I'm not going to labor the point any longer. Just know, ladies and gents, that the change in total revenue divided by the change in whatever the input is, it's fine. The next thing I want to talk about though over here is short run marginal cost. Now, when it comes to marginal cost for a business, I don't know if you remember when I said earlier that we assume that capital is fixed and we vary labor around it. That's just an assumption that we make over here. And when we say W, we're saying what is the wage rate per hour of a staff member divided by the marginal product of labor, i.e., how much product per that given hour does a staff member produce. And obviously, ladies and gents, if the production is higher than the wage rate, no worries. That's why whenever trade unions in our country try negotiate increases, what's always touted? Efficiencies, no worries. Because what's an increase? Well, it's irrelevant if the efficiency increases. Okay. Average variable cost, I don't think I need to explain these things to you. It's not rocket science. Maybe the only thing that may be complicated is, am I making, it is rocket science. What is it? Okay. Or, huh? Oh, okay. The only thing that I may need to explain is what we mean by second order conditions. So what we're having a look at over here is that marginal revenue equals marginal cost is what we call a profit maximizing function. Why is it a second order effect? Because when you have a look at a total revenue, first of all, ladies and gents, is the first number. It's price times quantity, right? But we have no idea what's happening to the marginal revenue as we sell more or the marginal cost as we produce more. So what we do is we take the first derivative. Has anyone ever seen what differentiation looks like? Okay, so everybody virtually said yes. Total revenue, and I'm going to need to make something up, is 40 plus 2q squared, or say 40q plus 2q squared, or whatever it's going to be. So what we're going to do is, technically what we do is there's a hidden exponent there. We take that number down into the front, we minus 1 from the exponent, and we drop off the end term. Okay, so that's what we mean when we take the first derivative when we differentiate. That's why that marginal revenue is, well, first derivative, second order effect. Now, just keep this in mind and trust me that profit is maximized where marginal revenue equals marginal cost. Let me ask you this. Those Krispy Kreme donuts, you can see as so many people have them. That and mug and bean tonight. I've never seen this before. But anyways, what we're looking at over here is those Krispy Kreme donuts. Every extra, how much does a donut cost? $15. Hey, yes, you oaks are. There we go. Sprinkles. There we go. What? I have no idea what's going on. I don't want to know. We're gonna stick to the. So let's say $20. Every single time Krispy Kreme turns out one of those donuts, it costs $20. Let's say for everyone they make, it costs them $5. Are they ever going to stop selling more? No. But what happens is as soon as they fill up their ovens running the entire day, what do you need to do? You need to buy another oven. Another oven, you pay for the cost, you amortize it, there's more electricity. Suddenly it goes from $5 to $10 to make. And you repeat this exercise. You as a business owner are always going to be producing more and more and more until what? The cost of making the next donut equals the revenue of selling it. Okay, the extra money you can earn. That's why you stop there. Now we move to totals, ladies and gents. I just want you to know the following, is that total variable cost will always increase with the level of production. Okay, obviously the line's kinked because there's changes at the margin that happen. See how smooth it flows off the tongue, okay? So use it in the office, you'll be waxed. But what I want you to note is that that distance should technically always be equal to the total fixed cost. Okay, so just graphically, it's not meant to be like that. But only when you have a look at averages does the averages converge. Why? Because a fixed cost over more units gets closer and closer and closer because it's a smaller amount per unit. So on that basis, just don't be fooled by it. But there we go, ladies and gents. Total cost is always going to start from total fixed cost, and if that needs explaining, we got bigger problems. Okay. I'm not going to explain what these different costs are. You can have a look at it. This is where I want to take a moment. Okay. Just by the way, STARX, I know for the early start. Okay, that's Starkey. I didn't make that up. That was Russell. So I'm not giving myself credit, but my nickname is Starks. So now, what you do, ladies and gents, you have a look at this graph. This Starks acronym over here is essentially just trying to help you to understand this graph. You can see all the letters scattered around. Just as long as you understand the following, that firstly, average fixed cost declines. In reality, what you'll see is fixed costs will increase and increase as you get kind of another. You have one electricity plant, your fixed cost goes down, you build another, it increases for the country again, and you get the point. Okay. Now that's easy enough. What I want you to understand more importantly is what this variable cost and average total cost moves like. Okay. As you'll see, the gap narrows now between average total cost and average variable cost, because average fixed cost gets smaller and smaller and smaller. And as it tends towards the x-axis, so too will those lines get closer and closer and closer. Can you see that? Okay. Now, the last thing I want to show you is what happens with this marginal cost curve. What is the marginal cost curve? Say it says, what is the cost of producing one extra unit of good for this company? Okay. What did I tell you? We're always going to keep in mind that marginal revenue equals marginal cost. That's where profit is maximized. But have a look at this. This is what I said earlier, the third point, that marginal changes drive everything else. Where is average variable cost at its lowest point? Where marginal cost intersects it. Because if it costs me, I think in the early start I gave the example of tests. Let's do tests. Your first test you write, you get 50%. Okay. What happens if every single test you write for the rest of the semester is also 50%? What's your average? Okay. What happens if you go from 50 the first test to 40 the next test? Your average gets pulled down. Now, what happens if you've written 5 tests in a row and it's 50%? And the very next test that you write is now 60%. It's going to slightly pull up the average. So as long as marginally, check it there, here we go. As long as the margin is below the function or above the function, it's always going to pull the average up. That's what I just want you to see about the margin. So wherever something's going to be at its lowest is where the marginal cost will intersect it. Okay. And obviously highest where the marginal revenue intersects the curve opposite. You get the point. Okay. So as long as you can see that, that's going to be fine. Now, while we're talking specifically about this marginal cost curve, I want to take a moment to ask you this. It's not a tangent, I promise. It's in here. It's in your notes. Let's say we can sell a good for a particular price. So let's call this $10. There's price. There's quantity. Okay, there's 10. Okay, what does this line being flat mean? It means I can sell as much as I want at $10 and there'll always be someone. There we go, exactly. So let me ask you this question. If you can sell as many as you want at $10, you can sell as much as you can make, people will buy. Would you ever drop your price to increase demand? Never. It doesn't make sense. That's why it's infinitely elastic. Well, if you increase your price and I'm making the exact same thing, to zero. No one's going to buy bugger all. Check it out. I'll compete you. But anyways, now I want to ask you this. You've got marginal cost. And in that last graph, I showed you it looked like that, right? Everyone happy? Your marginal cost curve is upward sloping. So in the beginning, there's some efficiency. As you add things on, marginal cost gets lower and lower and lower. But I want to ask you this, and I'm not running in a tangent. This is in your notes. I told you very clearly that where you're going to produce to maximize profit, where marginal cost equals marginal revenue, right? Can you see that if I'm at this point over here, by selling an extra unit for 10 and making it for whatever that is, 3 Rand, I'm making 7 Rand by selling the next unit. So where am I going to make the most profit? Where? There it is. The maximum profit. Okay. Now, why would I not make it at this point over here to the left, where the green dot is? That point over there, ladies and gents, is also where marginal revenue equals to marginal cost, right? It's the profit maximizing condition. There's two constraints. The first one is that it's marginal revenue equals marginal cost. The second one is that it's the upward sloping portion of the marginal cost curve. Who can tell me why? It all comes down to quantity. Check this out. If we have that yellow section over there, imagine the curve went on to the left. We needed to start selling from 0 to the first unit, right? We were making a profit or a loss on that first unit. No, yellow section. Loss. The cost was more than the first unit to make. Think about in the investment management game. On day one, you need your chief investment officer, you need your analyst, you need your overhead. How much money do you have to manage on day one? A lot of nothing. Okay, unless you get seed capital, but a lot of nothing. What that means is the first rand that comes into your fund that you charge your percentage on, you're making a loss. And you make a loss cumulatively all the way down to once you start passing that line. Now, what I want you to say, let's imagine this blue line, your cumulative losses equals 100. Okay, that's your loss. You're in the negative. Whatever, negative net profit, it doesn't matter. You need to get beyond that point and start recouping some of that loss to break even cumulatively past that. And only then do you start making money again. So that's your condition why you only do it on the upward sloping portion of the curve. So we'll skip over that section when we get to it just now as well. Just wanted to talk about it. Okay, ladies and gents, you're going to get probably a table that looks like this. Or it's going to be in a question. As long as you can understand that average fixed cost equals the total fixed cost divided by the quantity, and you can repeat it for all these blocks, I think you should be fine. So I'm going to take this offline, that if you're not fine with these kind of generic things, please do reach out. I will happily sit with you to take you through it to make sure that you're fine. We've seen this graph already. That's fine. We've seen the marginal costs. We've seen that it's U-shaped. Why is it U-shaped? Because the average always comes down until the marginal crosses it. And, okay, you get it? Now, we've already spoken about this over here, ladies and gents, and we'll speak about it in the next section. So when we get to it in the next section, which is reading 15, I'll skip over this. We'll move on quickly. But what I want to talk about is that there's a difference between perfectly competitive firms and imperfectly competitive firms. And what a perfectly competitive firm says is, we sell exactly the same good. That Coke that you're drinking and this Coke I have here in the front, they're the exact same good. You can buy the same Coke from the same vendor or a different vendor. They're the same product. They're fungible. So what that means is that it doesn't matter which firm I go to. Every single firm that sells a bottle of Coke is, for all intents and purposes, perfectly competitive. Imagine, for the sake of it, that every single person in this room knew, for some miraculous reason, what every single shop price for Coke was here. Exactly. Now you know that number. Anybody that's above that retail price suggested number, you're going to buy from them. Okay. Drops to zero infinitely. So what I want you to see is that the demand curve is perfectly horizontal, because as a supplier in this market, you're a price taker. You can't increase your price or else nobody's going to buy from you. You're not going to decrease your price because you can sell as much as you want at that price. And that's perfectly competitive market. Now, if I score 50% on my first test, and I score 50% all the way through to my 10th test, what's my average? Correct. Now let's say I write my 11th test and I get exactly the same mark. What's my marginal score? 50%. Whatever the mark of the next test is. That's why price equals marginal revenue equals average revenue. You may get a question on that. Okay. Now, let's go to an imperfectly competitive firm. Bless you. What did we say earlier about the law of demand? If I want you to buy something from me in larger quantities, what do I have to do to the price to convince you? Exactly. That's why for an imperfectly competitive firm, there's a downward sloping demand curve. What's this curve in the middle over here? That's perfectly halfway, not by coincidence. It's a marginal revenue curve. Okay, and it's perfectly halfway because when you look at a total revenue function, one of the terms in the total revenue function will have a square in it. And when you take the first derivative, you differentiate, you bring the two down, perfectly halfway. That's why marginal revenue in this setting will always be halfway. That's why the maximization of profit, which we saw earlier, halfway. Can you see that as marginal revenue goes below zero, start making a loss, and hence it trends downwards? Can you see that? Okay. So we've gone through everything over there. That's fine. We'll skip over it in the next section. No problemo. Now, this is where we need to start identifying a couple of things. Ladies and gents, I want to ask you something. If I'm doing something right now out in the market, and my return on invested capital is like, it's ridiculous. It's like 70% every year for the past 10 years. It's crazy. Do you think somebody in this room is going to try to compete with me and earn some of that pie? Okay, now, I'm not going to be able to keep that forever to myself unless I've got some moat, some monopoly characteristic in the market. So what we're going to start having a look at with these curves is you need to be able to quickly have a look at these curves and see if a company is making profit or not. Okay, so you understand step by step, we're going to find where does a company make a profit, max profit, where marginal revenue equals to marginal cost. So what do we have? We have our short run marginal cost curve, and we have our marginal revenue curve. Where do these two curves intersect? Well, there it is. Now, ladies and gents, what cost at that level of units will a company pay? There's two types of costs, fixed and variable. You add them together, you get total cost. Now, for that number of units, you divide by the quantity, so there's average total cost. So what you do is you take that dotted line down to where the average total cost curve is. You draw it across. Now what this tells you is that this company is making profit. But now, I want to ask you this, ladies and gents, is a company allowed to make profit? Yes. Do economists specifically consider what the return on equity must be and that must be paid back to it? Economists do, not accountants. Economists will say whatever's on the bottom line for net profit still needs to have the return to equity deducted off. Accountants will say just leave that net profit there. So now, when we as economists say a company is making zero profit, we have what as an expense? We have return on equity as an expense. So zero profit, break even, means I've already paid the equity holders and debt holders. So now this green section over here, is that profit above what we expect the return on equity to be? Yes. What that means, ladies and gents, is when the average total cost is not sitting exactly on that profit maximization point, there is a excess economic return. If I expect 20% ROIC and I'm earning 40, you'll see the green line. Okay. What I want you to know for a perfectly competitive firm is that that is not possible in the long run. Only for monopolies or oligopolies, we'll talk about that just now. Okay, that's fine, that's fine. Okay, we spoke about this already. This is where we said, is it going to be better to shut down, to close permanently, whatever the case may be. Okay, so we've already talked about the continuing to operate in the short run. That's where you at least have something greater than average fixed costs. You don't have enough resource to pay for all of the fixed costs, but you have enough to at least put a dent into it. Okay. Now I want to ask you this. If I can sell something for $10 and my cost to make it is $12, what am I going to do to the hole? Am I going to make the hole deeper? Yes, Because every single time I sell a unit, it gets 2 rand deeper and deeper and deeper. And I've still got to step into this hole to pay for my fixed cost. Okay. So in that instance, ladies and gents, no matter what the situation is, if you cannot cover your average variable cost, you're done. Don't worry about it. Don't even look at it. Just move on and call it a day. Okay. So that's how you answer these types of questions. But as long as you can pay for some of your fixed cost in the short run, and the question will say it's expected to be temporary, it's expected to improve, whatever the word the question uses, then you say, cool, we'll take the loss in the short run. Why not just shut down and then open up again when it improves? Because then you have to pay for all the fixed costs. If you read the book, The Floor of Averages by Sam Savage, reality, we take a little bit of a different slant, because if you have optionality on production, you have the option to turn your production online when prices suit you. Slightly different, but everyone gets the point. Okay, now, what happens over here, ladies and gents? There's your marginal cost curve. If your price only covers your marginal cost, that's where you shut down. Okay. If your price covers your marginal cost plus your fixed cost, how do we know that's the difference? Because average total cost minus average variable cost equals average fixed cost. There it sits. That's your break-even point, and I think you get the point. We've already showed you an example, and here, would I learn this table? I'm not a fan of just learning things parrot fashion, because I tend to get more confused than it works. I'm a very slow learner, but just think about it in the examples that I've tried, and if it works for you to just memorize this, then do it. But should you expect a question on it? Probably hell yeah. Okay. Break-even analysis. I just want to show you how to read this. And once again, we'll see a very similar learning outcome statement in the next reading. So we are chiseling away at the next reading as well. Don't worry. How do we read this? Where do we first go to when we draw our attention? Profit maximizing is where? Marginal revenue equals marginal cost. Short run marginal cost, marginal revenue in a perfectly competitive firm. There we are. Can you see how this bolded average total cost line sits exactly on that crossover point? So what I see most accountants tend to do is to think, okay, well, if what I'm selling this for equals my total cost, where's my profit? That's a problem. But bear in mind, as an economist, profit's already in that total cost number, because economists always care about opportunity cost. Now, we're going to take this over to a monopoly. Now, ladies and gents, if you do any market structure, this is how it works. An individually perfectly competitive firm can have that flat horizontal line. But for the market as a whole, the entire sector's demand curve is downward sloping. So don't get confused by that. Now, if we move away from perfect competition and we go to monopolistic competition, monopolies, oligopolies, you'll see that the only way for a company to entice you to consume more is to drop the price. Can you see that? Drop the price, you consume more. Okay, now, let's have a look at whether a monopoly can make profit in the long run. Okay, so there's your marginal cost curve. There's your marginal revenue curve. What do? Where they cross, we take that price and we take it down to the average total cost curve. What do we see? In that situation, is the monopoly making a profit? No, it's not. Now, why on earth would a monopoly not produce where they can get that average total cost curve line lower? And that's what we're going to see in the next section. And specifically, if they're making an excess profit, how do we get that away from them? There's 3 different methods that we can use. Okay. Economies of scale and returns to scale. Ladies and gents, does anybody here work or works with a manufacturing company? Okay, yes. Can you give us some example of what you do or what they do? What do they manufacture?
In mining and quarrying, it's part of manufacturing is having different yields. The product that you put input, you get out 20% of a certain rock, 35% of something else, 20%, 30%, and then these yields are used to basically become.
Now, let me take your quarry example, your mining example. Can you envision a situation where you put 1 metric ton in? How much comes out after you put 1 metric ton in? Give us a 1 metric ton. Now, how much of that 1 metric ton on the other end is usable? Virtually all of it. But let's say there's a small loss. So for our example, can we say you lose 10%, 1% waste of it? Now, let's take a situation where you change your technology. Okay. You put the same 1 metric ton in through this process that was described, but instead of losing as much, you lose half now. What's changed in that situation? Exactly that. Now, that's what this says over here. That's what returns to scale says. For the same process with an improved technology, I get more out on the other end. That is not the same as economies of scale. Economies of scale, that says, cut that plant size or that quarry size that you're talking about in half as it stands. Okay, cut it in half. Not different technology, not anything else. What is the cost of processing each metric ton going to be then? Okay, same input to output loss ratio. Okay, I still lose 1% no matter what the size is. Okay, it's not that. But now I double the plant size and I get my metric cost per ton down, I don't know, $10, $20. You get the point. So the bigger the plant size, the lower the cost per unit, the better the economies of scale. Not returns to scale, economies of scale. This economy of scale says you get too big. Okay, but there's wonderful books out there. Anybody know the company 3M? If you go to Woodlands Office Park, you see they've got a building on the corner there. There's a wonderful book that's been written about many companies, them included. They embraced this diseconomies of scale thing, and they've done fairly well. But the point is, it says, once you get too big, the organization's too cumbersome, there's overlapping functions and expenses, you tend to have a disadvantage by being too big. What we are going to look at is you need to be able to look at a curve and say, should this company increase or decrease production? Simple as that. Now, how on earth do you read this graph? That's cost on the y-axis. That's size on the x-axis. Now, when you produce, what do you want the cost to be? Higher or lower? Okay, we have some faith. Okay, it needs to be lower. Which one of these is lower? 3, 2, or 1? 1. Okay. Now, what this means, ladies and gents, is that if you're only going to produce a small quantity, you can see that even though the gradient of short-term cost 1 is the highest or the steepest, you're still going to produce in the smallest factory. You only get benefit at that point from 2 as you increase to that size, and only if you know you're going to produce a shitload, then what you're going to do is you're going to go and invest a lot of capital. I should have used a better word, eh? Just came up before I could even stop myself. Okay, yeah, take it. There we go, just good. Okay. We spoke about increasing returns to scale. We talked about that. That's fine. Decreasing returns to scale, just make sure you go back to read that example. You will get a question that asks you, should you increase or decrease production? That will help you answer that. Now, this is a little bit interesting. When I spoke to you earlier, I said, what do we assume? We assume, you mentioned diminishing marginal returns. Diminishing marginal returns is when one thing is fixed, right? Think of the students and the size of the room is fixed. Now, in the long run, is everything variable or fixed? Exactly. So in the long run, I can change the size of the room. I can, from Nedbank, increase the space and rent there, right? Or I can agree for them to take over this whole section and we only take that. But not today, maybe in a year or 2 or 3. Now, what you're looking at over here is different cost curves for different levels of capital, which is fixed in the long run. So every single small arc that you see is, online students, every single arc that you see is for a given capital level where you vary the other variable input to the process. Okay? And if it's labor, you increase and decrease labor. If you take that range for every single level of production in the long run to an infinitely large imaginary company, which is on the far right, to the small company on the far left, as you can see, now we move from the short-term cost curves to the aggregate long-term cost curve. And what happens is we tend to just draw a smooth line through it. But as you can see, this is how it's comprised theoretically. Okay. So that's not really how your question's going to look insofar as I've seen. What your question's going to look like is, and I'll come back to that in a second. I will come back to this page, but follow me over here to whatever number that is, page 30 or 29 or 31 or whatever. Your question is going to look something like this. You're going to have, on the far left, the line decreases. That's economies of scale. Your costs go down as you produce more. On the far right-hand side, the line slopes up. Diseconomies of scale. As you produce more, your costs increase disproportionately larger. Then you get this flat section returns to scale. You put one in, you get one out. Simple as that. Shake it all about. Cool. As you can see, I got energy. But anyways, the question's going to ask you, you're sitting at this point here for the red line, or you're sitting at this point here for the blue line. What should you do to production? Well, blue line increase, red line decrease. Simple as that. If I'm going to circle back now to where I started skipping, I've seen one or two questions ask, what gives you this benefit? And I want to ask you this. In management accounting, I can't remember, but I know Eunice's management accounting teaches you learning curves and how to calculate them. Okay. Everybody's experienced this in reality. You do something for the first time, you start a new job, it takes you a long time. A couple of years into it, it's just waxed and it's second nature. It comes quickly. That's what happens over here. Another thing I believe very strongly in as well is division of labor. It is more efficient, instead of 5 people each cutting the wood, then bolting the legs on, then painting it, then delivering it. You have one person that cuts, one person, but it all comes down to setup time. Think of any process. If you need to change the dye peblets in the injection molding here from red to blue, there's downtime there. There's uptime. You've got to change the pellets, clean it, get the wax out, a couple of wastage injection molds as you work the blue through the system. That's what the point is. If you focus on one thing, there's less downtime. Also, the learning curve flattens quicker. And then mass production, that one, it's easy enough. Let's see where we sit in the bigger scheme of things. Okay, like I said, it goes quicker because there's just lots of images. Oh, and this last one, just theoretically, the lowest point on the far right-hand side is, imagine we had one producer that produced one thing for the entire world. That theoretically would be the lowest far right-hand side of the long-run average total cost curve. Actually, I don't even think I've ever seen a question on that. Okay, but it just basically says, will costs go down as firms increase in size? Theoretically, it should from an economist's perspective. But in the long run, yeah. Okay, well, we can conclude reading 4 there. The good news is, what we'll see is there is a bit of overlap. I know there's 30 pages in this section as well, including the 2 covering pages, but we can skip through a lot of this. So, describing the characteristics of each different type of market, some of the stuff we can speed through. Okay, we've done it. Anyone over here recognize marginal revenue, marginal cost, economic profit, elasticity of demand? What do you know? Okay, now we're going to talk about a supply function a little bit more in detail, but I already showed you. Supply function is the upward sloping portion of the marginal cost curve. Why? Because you're not going to produce over there, you're still trying to recover a loss. Okay. This is going to be a bit of a tricky one. When we get to oligopolies, you're going to look at me when we try to determine optimal price and quantity, and you're going to say, we don't want to, okay. But we'll work through it anyways. Pricing strategies, extremely interesting. Anybody ever seen this movie, just to get you excited? A Beautiful Mind. So you've watched that movie. Have you watched that movie? No, you're trying to remember. Go watch the movie if you just want to, relax. You've done your study hours, because it's based on that particular man over there, John Nash. But anyways, we're going to cover that in that section over there, optimal pricing strategy. We're going to talk about concentration ratios, and we're going to try use those different metrics to try and tell you what different type of market in. And I'm just going to add in what's called the HHI index, because it's not in your notes. Okay, that's all. So, ladies and gents, I think this table is going to be fairly easy. I'm going to start with a monopoly. Give me an example of a monopoly in our country. Well, it used to be a monopoly. Okay. Why did I say used to be? Exactly. IPP stands for Indian Premier League. IPL. Never mind. It's late at night. Independent power producers. Just joking. I even messed up the IPL. But anyways, one producer, it's easy to see that electricity is electricity is electricity. There is no close substitute. Okay. There's fantastic documentaries to watch in that, just by the way. It's awesome to see. But anyways, the whole point is that there's two different types of monopolies that exist. There's a monopoly that exists because there's some protectionism, there's some sort of government backing behind it, there's licensing, there's patents, whatever it is. Okay, it's not called this, but let's say it's an unnatural monopoly. Then we get a natural monopoly that only exists because a market is only a certain size which is big enough to only support one producer. Okay. Imagine it requires 55 million citizens to run a power plant in South Africa. What happens if two people now try and produce? What you're going to see is that their average cost is above what they can sell this for. And what do you know? One of them needs to disappear because there's a natural economy, a monopoly. That's what natural monopoly means. Okay, it's a size thing. What else can I say? Collusion is irrelevant. We'll talk about that in oligopolies. Long-run economic profit can be positive. Okay, there's only 3 instances where it won't be positive, and that all comes down to some various forms of regulation. Okay, but that's easy. Let's move on to the other end of the spectrum, which is commodity producers. And if you go look at the Reserve Bank's website, they have a look at a couple of these things to see how inflation passes through the economy. You'll see things like commodity producers tend to be the same. So you'll see some people use GMOs to differentiate themselves, or you'll see some people produce white mealies instead of yellow. Little differences like that to try and turn it into monopolistic competition. That's the main difference, by the way, between those two. Everybody tries to differentiate their product through marketing. That's the main difference here. But back to perfect competition, a couple of points to note. Everybody is a price taker, flat line. You raise your price, you sell nothing. To drop your price, you can, but you'd be certifiably insane because you can sell as much as you want at that given price. Yeah, that's everything. Goods are the same. Okay, I spoke about monopolistic competition. I want to, where does it say? Goods, differentiated goods. There we go. Where, if you are an accountant, if you are an analyst, if you are a business owner, would you see this come through, that differentiation, in an income statement? What happens if I can differentiate a product? If there is no close substitutes for a product, what do you think happens to what I'm able to sell it for? Does the price go up or down? Price goes up. What do you think it cost me to produce that good? Do you think that matters? It would have cost me the same in any situation. Cost of sale goes up, stays the same, price goes up, gross profit margin. That's where you see the difference come through for the differentiated. So if somebody's able to differentiate themselves, you'll generally see it reflected in their gross profit margin. Unless they're a low-cost producer, and we'll see what happens to the demand curves under that situation. Ladies and gents, I'd read through the rest of this. I can't do it any more justice than explaining this to you, as I have already. So what we're going to have a look at for each different type of market structure is what affects it, i.e. we're going to say how many different firms are competing for a perfect market, i.e. there's going to be an infinite amount of them, or remarkably there's going to be one. So we're going to go through each of these in turn. But what affects the market structure, the number of suppliers, the differentiation, the power that we have as suppliers to control the price. Shui, I don't know a lot about risk management for suppliers or key commodities. Or didn't Sasol create their own? They helped somebody start a chemical plant so that they could get an extra supplier and decrease the risk or something. I think something like that. That's Sasol having power over pricing decisions. The relative strengths, both on entry and exit. If you start a nuclear plant, you just can't in 10 years walk away from it and say, there's decomposed uranium sitting there and we're going to just leave it there. No problem at all. Okay. If you read a cool book, Michael Lewis's The Fifth Risk, that's a boring book of his, but he wrote The Big Short and Liar's Poker and those types of books. He talks about that. Barriers to exit. If it's going to cost you $1 billion to clean up a plant, you're probably not going to start in the first place to do it. And degree of non-price competition. Who in South Africa competes the most using that? Non-price competition, extra service, extra bang for buck, extra features, discovery. Mr. Adrian Gore, certainly he doesn't worry about charging more, that's for sure. But you're so right if you're talking about these banks. Banks compete. They're the South African oligopoly that everybody uses as a case study. Okay. Read through the rest. We'll go through it. Ladies and gents, I'm not going to go over each of these factors. You're just going to read through it. I won't do it in justice. Until we get to oligopoly, I'll talk about that. But demand-supply analysis in a perfect market. The entire time, I've been showing you that the supplier in a perfect market has a perfectly horizontal line, right? Now I'm showing you that it's downward sloping. The note there says that even though an individual firm has a perfectly horizontal line, they are a price taker. In aggregate, the law of demand still applies, and that's why you see that downward sloping, because it's for the market. Now, what do you know? We've spoken about the income and substitution effects. We're going to see this a lot in this section. We'll skip over quite a bit. What do you know? We've already done all these various functions. Okay, don't worry about trying to remember that is the average demand, average revenue function. It doesn't do it like that. Just remember it logically and you should be able to work through it. Talked about elasticities, blah, 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 it's fine. We've talked about all of this. We've talked about inelastic, elastic, and unitary elastic. And what do you know? Horizontal and vertical lines. Okay. Going to skip over the next section as well. And I want you to go to, please tell me this is on page 6 or 7. I want you to go to this section over here where that marginal revenue equals P1 minus. Is it page 7? Okay, thank you. Now, ladies and gents, what does this tell us? This equation over here is telling us what our marginal revenue is going to be for a given price level and a given elasticity of demand. Price elasticity of demand, to be correct. Now, for the other people who studied economics in this room, I want you to know what I'm about to tell you does not apply for your exam. When you remember for the exam, you remember exactly this. That's the formula that you use. That's what you remember for the exam. Now, what I want to show you is the following. Last year, I looked at this. For the people in the early start, I looked at this. This year again, I looked at this. I do not know calculus well enough to derive this. As you see this, I mean, sometimes it's long. It's like a page like this of calculus. But anyways, the point is, what you see in the top left here, that takes precedence, and that's what you see in your material. The bottom right is what I studied in economics and maths. Okay. When I did my mathematics and economics course, that's what I studied in that many different sources, and you can find it online as well. Why is one a minus and one a plus? Okay, so what I want you to remember, just say Rob was antsy about this, he got on a soapbox, always use the minus. Now, why does it matter? It matters because when economists use elasticity of demand, the sign matters. Because if there's a negative in front of it, there's an inverse relationship, right? So you can't just arbitrarily drop the sign, or else it goes from a complement to a substitute. Just like that. You can't. Econometrics doesn't allow you to do that. So what I did is for the price and elasticity of demand, and these numbers, by the way, are from a question at the back of your CFA book. So if you use this example, you've got your answer. Now, and I've left out some other stuff, but you'll recognize those numbers when you get there. If I use the CFA method there, you see the little minus come up. The number that comes out for the marginal revenue there is 46.67. If I use the other method down here, what you can see is that the answer that comes out is a minus 36.67. Okay? You can drop the sign. Now, if I use the CFA method with the minus there, and I put a minus in front of my particular elasticity of demand, then I get the same answer. So for those of you that have seen this before, and for those of you in the early start course, you would have seen that I previously didn't have the solution to it, so I'm making progress. But the point is, now you've got hopefully a mark to bank because you remember I complained about something. And if you do the questions at the end of the book, you'll see this again. Okay, so just want you to know I'm going above and beyond and not just blindly trusting the CFA. But who would I rather believe, CFA or me? By dawn, there's like 50 PhDs there. So I'll figure out where I'm not understanding it somewhere, somehow. Okay. Now, ladies and gents, I want to completely tangent and change topic to something else, to this concept over here. Consumer surplus. I remember talking to a couple of you about this before, so let's do it again. Anybody collect anything that is different or arbitrary? A unique collector's item? Actually, I'm going to use something because I am such a geek. Check out this. This little thing, Francis Galton, but check that I showed some of you earlier, so you're just going to have to endure it again. What this is this is called a Galton board. You have beads that drop out of the top, and they can randomly fall anywhere where they want, and what you'll see is that they fall neatly and nicely into a normal distribution. Now, why on earth am I showing you some arbitrary desktop toy? The point is I want to talk about consumer surplus. Okay, as you can see, let's just let it fall down, and you can see for the most part the law of large numbers applies. There's a normal distribution. Go over, look at it. You'll see all these triangles over here, binomial tree. You can get I think it's the Fibonacci sequence on the right. Okay, but anyways, ask me where I got this good from. Can you get this good in South Africa? No, you can't. You have to order it in from the United States. Now, can I ask you what the price of this good is going to be if I'm the only one ordering it in? Is it good? Exactly, it's going to be higher. Now, what happens if every single person in this class was willing to consume this good? Exactly, price will go down. But let me ask you this. Who here cares about that little toy? It looks a bit cool, but who's actually going to go find it in America and bring it in? Not you. I can see. Okay, tough crowd. You see, everybody has their own little quirk that they're willing to do. What that means is I'm willing to pay more for this good than you are. Okay, but let's say I hold my purchase back of that good, and I wait till everyone in this room gets it brought in, and then I buy it at 70% of the price. What's the maximum that I was willing to pay? I'm not going to tell you what I paid for it, but anyways, let's say, No, it's not that expensive. It's just a waste of money. But anyways, so this is what happens. Is I know I'm weird. Everybody has their own little thing, but so what? Everybody recognizes this, right? I would be that first one person that brings it into the country over there, whatever that price is, $100. I wait to buy when it's down to $50. So when I wait to buy, when everyone else says, okay, I need to induce people more spending, I would now theoretically have saved 50 Rand in worth to me, right? Bob's your uncle. There we go. That whole section there is consumer surplus. And it means that when we deal with consumer surplus, we also change the name of what we call that demand curve. We call that the marginal utility curve. What's utility? The benefit that I get from something. How much benefit am I going to get by buying a second one? Okay, probably not a lot, but explain that to people who own 8 cats. But anyways, that's fine. What that means is that my utility is lower, my happiness is lower by purchasing the next unit. Okay, now, that's why when we've gone over here, we've said that it is consumer surplus value minus expenditure and the marginal value curve. Okay, I think everyone understands that. There it is over there, explained to you in an actual example. Now, what I want to do is I want to go to a typical question that you will get if you have a look at this in your book. Yeah. You're going to get a situation that looks like that. What is the value of the consumer surplus? Half base times height. You must be able to work out that number, just by the way. Simple as that. Half base times height. Base, height. Now, the question's going to tell you that every time you go and visit this gym, you pay €2 to go to the gym for that day. Okay, now the question is going to say, how do we extract that consumer surplus? What's the maximum amount I can charge you as a fixed monthly fee that you pay me once off and you still continue to pay that €2 every time you come? Ladies and gents, what I want you to know is that that maximum fixed charge that you can charge with a variable cost is going to be equal to the value of your consumer surplus. So if you see a question come up like this in your exam or at the back of your CFA book, where that's from, okay, no, that's an example in your text, not at the back. This question doesn't really get spoken to anywhere. That's why I've specifically added in here, and it can throw you off. Okay, so that's one way people can extract your consumer surplus. Okay, you pay your variable costs and you pay once off fixed amount. Let's move on now, very rapidly changing tact to monopolistic competition. I honestly think if you just realize over here that the individual's firm is downward sloping, you need to induce people to buy more, and your product differentiation occurs, you got it waxed. Okay. I want you guys to run me through this. We know for perfect competition, where do we maximize profit? Marginal revenue equals marginal cost. Does that change for monopolistic competition? If you don't know economics, no, it doesn't. Now run me through where this occurs. In this situation, are we making a profit or not? So, would you agree that short-run marginal cost curve, marginal revenue curve, profit maximization point is there, right? We go up to where? To where the cost is, right? Which is just a hop, skip, and a jump up here. And that's what it cost us to produce the good. Where are we selling it for, though? Selling it up here. Now, if they tell you that that's 10 and that's 10 and 5, are you able to calculate mathematically what the excess profit is? Length times breadth. Okay. So I want you to be able to see. Okay, now I'm not going to do it. Tell me how, in this situation, the profit goes away and why. We or the market as a whole produce more. You hit the nail on the head. Market produces more. Why would the market produce more? If I'm making handsome profit like that and you guys see that, what are you going to do? Come compete with me, right? And as that happens, more supply comes to the market. Now, tell me where this average cost curve needs to go to get rid of that excess profit. Which direction does it need to move? Exactly, up. What will need to happen, I hope you can see, let me draw it in this funny purple line, is that it needs to sit there. Can you see that? So the exact same thing applies to monopolistic competition. You cannot make profit, excessive profit in the long run. Sorry, excessive profit. Okay. Let's move on. Oligopoly. Okay, I hope we are going to start skipping through this a little bit faster. Don't worry, but we do have a little bit to go. Sorry. Oligopoly. Let's understand the differences here. I'm going to slow it down. Firstly, ladies and gents, this is a market where everything is interdependent. I have not yet talked to you about competitive theory. In a monopolistically competitive market, if I try to differentiate, what do you think my competitors do? Do they even give a crap? No, they do nothing. They are not reactive. They are not proactive. In an oligopoly, this is where things change. Okay, and this is where the beautiful mind came from John Nash and game theory, prisoner's dilemma. The whole point is, what do people do in a competitive environment? And the first thing you need to note, the pricing decisions are interdependent. Your price change matters to me because my price change will react to you, vice versa. Secondly, if there was 1 million firms in the market, can we honestly keep tabs on what everyone's doing? So the firms are small enough that we know what everybody's doing and can affect each other. Okay. Now, what you'll see here is that the products don't have to be differentiated or don't have to be exactly the same. The whole point is that they're close enough. That's what matters. Okay, think of banks. Close enough. And non-price differentiation occurs. Now, I want to ask you this. Well, I think I remember doing this with the early class, so if I've given it away, please excuse me. But if a bank wants to compete by dropping their price, can they undo that later on? No, because imagine we're competing. We both drop our price, but you want your profit margin back, so you increase. Everybody's going to move from you to me, and I gain market share. That's why banks try, they've got a gentleman's rule to keep their prices elevated and compete with the service offering. Because can I turn the service offering, tap it down? Can I turn the advertising down to get my profit back up? Yes, as long as my competitors do it as well. But we can't get prices back up. Okay. That's that non-price differentiation. Or just go to Discovery, the behavioral bank. Which I saw him speak the other day, Adrian Gore. The man is he's amazing, hey? I don't believe in the high-cost producer model, but anyways, he never misses a beat. This is what I want to talk about over here. Your pricing strategies in an oligopoly market. Yeah, I know it's getting late, 9 o'clock, eh? And I always blame Mo when he keeps us here till 10, but this is one class we have to. I'm sorry, not till 10. No. These are the 3 ways in which we compete. Firstly, ladies and gents, pricing interdependence just says the following. A firm cares about market share. Market share matters. Okay, you will compete to the bitter end to maintain your market share. So what are you going to do if your competitor drops their price? You're going to drop your price. What are you going to do if your competitor increases their price? Okay. What that means is it creates a bit of a problem now because your demand and marginal revenue curves, it isn't one curve. You react differently to your competitors. And you may also have this curve kink again if you change your own tactic yourself. So, that's why you have this situation over here. What I want you to see is that there's a little arrow up, and over here there's a little arrow down. Can you see that you've got two marginal revenue curves depending on whether you go up or down? However, for the market, you can't just decide which one you want. What it means is your marginal revenue curve is different going down than going up. Okay. Now, what that means, ladies and gents, and it's easier to see it in the second graph over here, is that you've got a kinked demand curve for an oligopoly. And I'm not just talking about this because you're not going to get a question on it. I spend more time where I think you're going to get more questions. Okay. Now, that point over there, right at the kink, just make a note right now, and that is the most efficient point in an oligopoly. And another question that you're going to see often come up is, well, what's the pitfall of that theory? The theory, pricing interdependence, tells us bugger all about how we got there in the first place. It doesn't tell us if there's something structurally wrong with the market to make it elevated or lower. All the banks could be earning a bloody decent ROIC over there. Just by the way, if you go look on like your brokerage account and you see the high ROIC of banks, bear in mind you've got to make an adjustment to the balance sheet as well, just by the way. It's an artificially inflated number. What else can I tell you here? Okay. This still holds for every one of these different markets. Your profit maximization point is, I'm not going to bore you. Okay. So just know that that's the case for rule number 1, pricing interdependence. Rule number 2, suddenly now we assume profit maximizing level without the other firm's output changing. It makes our life a little bit easier to work through the problem, at least to think about it. But ladies and gents, working through this example, just imagine this in your mind. You're setting the CFA test. You've got all these calculations that are about to follow. You're thinking to yourself, how long has the student got to answer an average question? I don't know, what's it, 3, 4, 5 minutes or whatever? 90 seconds. So I just felt like there was a lot of time, 3 minutes, 4 minutes, listen to me. But anyways, let's work through this quickly together. And you tell me if it goes over 90 seconds. And then based on that, you ask yourself if it's probable to get this in an exam. Okay. So I've already wasted 90 seconds there. Now, see. So on your calculator, let's see if I've got it. Let's just use, oh geez, that's still going in the background. Maths videos, Russell's going to ask, what is it? Texas Instruments, is it BA2 plus, eh? Okay, so let's just go straight. Okay, we can't see it over here. But there's a little rand button just here. If anything fails, can you see that little rand button? Just eliminate one answer, and if it's click rand, and if it's above 0.5, go for that one. If it's below 0.5, go for that one. Okay, check that, eh? Because then you've got no bias. It's a random nature completely. Okay, now, follow me, ladies and gents. We're going at a tangent here. Okay, I want you to follow this thought process now with me. We are looking at a market in totality. Okay, so that over there is going to be the quantity demanded for the market. To make this easier to do, and you can do this with as many number of firms as you want, as long as you assume they all share equal proportions of the market. We're going to take that, and we're going to divide into 2 firms. It's a duopoly. Okay, so the easiest way is to just divide that right down the middle, but mathematically it's equivalent to saying that that number there is equal to firm 1's output plus firm's 2 output. You get that? Okay, so Q1 plus Q2 equals QD. We are then going to say we're still going to produce where profit is maximized at the MR equals MC constraint. They tell you that marginal cost is going to be 20. So somewhere, somehow, we're going to put something equal to 20. Okay, get that going in your mind. Now, what we can see is we got this function up here, which is the total market function, and we can rewrite it exactly the same as that. We just split the QD into Q1 and Q2. Okay, everyone with me? Now, we start to do some funny things. Okay, Not super complicated, but just like I said, juice is not worth the squeeze. Total revenue equals what? Total revenue equals price times quantity, right? Okay. So what we now do is we've got the quantity demanded for each firm in the market. We just times it by an unknown P. So what you'll see over here, ladies and gents, is PQ. So what we know in this particular example, everybody recognize that over there? Okay. We know that that's going to be equal to price. We've just flipped it on its head. Do you see that? Price left hand side, quantity demanded right hand side. So that's why we just simply add in another Q1, because that is going to be equal to price. That's going to be equal to quantity. So all we've done here is that's the inverse demand function over there. That's what we've done. And we just added on the quantity. Price times quantity, total revenue. Now, when you multiply this out, what you'll see, the 350 stays the same, except for firm 1 and firm 2. Each of them have their own quantities, Q1, Q2. But in your mind, you don't matter what you call that, because it's the same number. You're splitting the output equally. Now, the back of that, you get Q squared 1 minus Q1, Q2, or minus Q2, Q1, Q2 squared. You just multiply it out and you get, why do you get the squared? Well, whichever firm you're looking at, we're looking at Q1. So Q1 times Q1 equals Q1 squared, or Q1, Q1. Q2 times Q2 equals Q2 squared. Bob's your uncle, you get the story. Now, what we need to do, ladies and gents, is we need to now differentiate. Why? Because if you differentiate the total revenue function, you get marginal revenue. Okay? The first rate of change. What you do is, I'm going to start over here. It's a little bit small, but you see there's a Q1 squared. You take the 2 down, you minus 1 from the exponent. Anything to the power of 1, it's just itself, right? Okay. So that's why the 2 drops down over there and over there. Can you see that the term of the Q1 and Q2s, they drop away? Why? Because what is there? If I just take this, 350 Q1 to the power of 1. If I take 1 down, 1 times 350, and then Q1 to the power of 0 equals 1, you just drop the 1. Okay, so there we go. You got it. Now, I know it says simultaneous equilibrium for the 2. Don't confuse it with simultaneous equations. You remember, you insert 1, you solve it all. If you go back, you start again. You don't need to do this. There's a little shortcut over here. What we've gone and said over here, ladies and gents, is that we have swapped in, that's fine, 350 minus 2Q1 minus Q2. That's over there. But what I can tell you is that whatever Q2 and Q1 is, they're going to be the same number. We haven't weighted this. You can do it on a weighted basis. We don't care. Now, all that I've done is, and I'm progressing very slowly, but we're almost at the end. Can you see? I've just swapped that. Everything else over here is exactly the same equation. It's not a simultaneous equation. I've just substituted one for the other. And if you reach this point and you get that there with only one unknown and you can't solve for it algebraically, we've got bigger problems. Okay. So all you do then, ladies and gents, is whatever you get out over here once solving for it, for in essence, you just double it up to get each market share. You add it up, you get the total market. As simple as that. Now, I'm not even going to try ask you if you understand this or if you want me to explain anything more. It's not worth us doing it. If you get it first time, cool. If you don't get it first time, see. Simple as that. It's probably not going to come up in the exam. Don't waste your time for it. But as long as you know an oligopoly still is MR equals to MC, and that you split it down the middle for this corner assumption, monopoly will still try to produce there, but we may not let it. Okay. Why are we not going to let it? Have a look at this out. That highest price is your monopoly price. This lowest price is perfectly competitive price. This is where the Cournot assumption sits somewhere in the middle. Okay. Now, what that means, ladies and gents, is that under a condition of monopoly, there is going to be less quantity produced at a higher price, which means direct loss to consumer surplus. Okay. Now, if you were a business owner, which one of these three would you want? Okay. And if you're a consumer, which one would you want? Exactly. You got it. Cool. So that's all you need to know. You got it done. Now, just note this. The closer to the free market, the lower the price. The closer to the monopoly, the higher price. The reason I put that in there is because you may get a question on it. Okay. Last but not least, Nash equilibrium. Okay. This is game theory. I'm going to start this with an example to make it a real life context for you. I'm not going to ask who's committed a crime with a friend because I don't want you to tell me. So I'm going to ask you to imagine with me. Okay. I want you to imagine that you commit a crime with somebody. Okay. Now, you guys have been doing this for a long time. You're both criminals together. And one day, eventually, you get caught. Now, you've got a situation. If you both keep quiet, then each of you will only get 2 years in prison. 2 years equally spread across the board. You quiet, you don't talk. If both of you talk, each of you gets 10 years. You rat on each other, you both rat, you both confess. What is in your advantage to do in this situation? Not to talk, right? Now you've been robbing people and stabbing and killing people with this person for the last 20 years together. What's a criminal's code going to do? Why does this person care about you more than anybody else they've killed? What are they probably going to do? They're probably going to talk. Okay, this is where the problem comes in. Here's the trade-off now. If they talk and you don't, they get out of jail scot-free, 0 imprisonment time, and you get life, 25 years. And vice versa, if you talk and they don't, they get life and you get a walk. Now, in a competitive environment, what's probably going to happen? You are going to move to where it's advantageous for you to do so. And can you see that it's advantageous for both of you to talk? So both of you are probably going to end up with 10 years. And this is what game theory is all about. We call this prisoner's dilemma. And this prisoner's dilemma is exactly the scenario over here. Exactly the situation. 1 year life parole, blah, 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 got it out. But let's not worry about that. I want to go to a more realistic example just before we go to the bats and arrows one in your question book. It's not very clear to understand. Just by the way, John Nash was schizophrenic as well, so he'd be like in class thinking that he was talking to real people that didn't exist, and he was a lecturer, pretty cool cat. Yeah, it's weird. So if I start talking to the dustbin, you know what's up. Okay, but have a look at this. Starbucks versus SS Coffee has a competitive decision to make now. Do we advertise or don't we advertise? If neither of us advertise, we don't need to spend the money. And we both make $15 each. Okay. If one of us advertises and the other one doesn't, we make $20 and the other one makes 10. So now under a competitive environment, where can I directly improve myself here? Okay. Now, if you both advertise, you earn $12. Now I want to ask you this. What Nash equilibrium says is that you're at an optimal point where you can no longer take a decision that disadvantages either of you. Okay. Will this person opt not to advertise? They drop. Will this person do it? No. So that's the point. If both of them didn't advertise, there's a collective earnings of 30. Over here, it's a collective earnings of 24. And you can leave when you're ready because we're probably going to go for another couple of minutes. So just enjoy the ride, but until you need to leave. So that's the point, ladies and gents, is that probably in all of these examples that you see, you're never going to default to the one that is the highest combined price in most instances. So do not be lulled into thinking optimality is the highest combined. No, it's not. Okay, let's have a look at this. Arrows and bats. The decision is charge high price versus charge low price. And this is complicated to understand when you see it for the first time. Okay, it's taken me years to like let it truly sink in. But let's look at this. Let's start at the top left. If both of them charge a lower price, is there any advantage to either one of them independently to raise their price while the other one doesn't? So, Arrows continues to charge a low price, Bats continues to charge a high price. Okay. Do you think it would make sense for Bats to go from 70 to 0? They're not going to do it. Okay. Let's now go to where they both, let's swap it around. Arrows charges a high price and Bats charges a low price. Is it in Arrows' advantage to now charge a high price? They go from 50 to 300. Okay. Now let's go to the bottom right-hand corner. Is it in Arrows' advantage to continue charging a high price if Bats also charges a high price? Why? Because they can earn 500 instead of 300. So no matter what, Arrows is going to charge a high price. In every scenario, their high price means more money. Now, that's where I always used to default, to the total being the best. But let's go to Bats. Is there any way that Bats can make more money by changing their position? Charge a low price. So when they're sitting in this bottom left-hand block where optimality is, even though everybody in the ecosystem can earn more, it's not beneficial for them. So that, ladies and gents, tends to be the optimality point. It's the second best point. I know it's a terrible rule of thumb. It's not always going to work. But if you're confused in an exam, I'd say maybe 6 or 7 times out of 10, it's probably going to be the second most point overall. Okay. So it's not going to work. It's not foolproof. There we go. Now, let's skip a section because time is running short. Let's talk about collusion. What is collusion? Somebody explain it to me. They're both going to push up the price artificially. It's not illegal if you publicly declare it and suddenly you OPEC and control oil. Okay, go have a look at that. It's quite interesting. By the way, we're working with an economist that kept showing us that Russia was cheating and producing more than they agreed to. Okay, anyways, so it's not perfect, but anyways. If we agree to work together, we can get more money overall. So how is it possible to move from the bottom left to bottom right? What does Bats need to earn extra to break even? They will lose out by how much to working? $50. Okay. Now, what will Arrows gain by moving from bottom left to bottom right? So how much of that 200 do they need to share with the other party? $50 plus an incentive. So this goes, collusion is possible if 51 is given across. Okay, so that covers that section. Here we go. All right, here. Do you need to learn these 6 factors that affect successful collusion? Yes. Does this do it in injustice? Yes. Okay. So what a cost structure affects a successful collusion? Does a similar or different cost structure affect a successful collusion? Well, similar cost structure. So what I suggest, ladies and gents, is just go and have a look at this. If there is lower external competition, you're more likely to have a successful collusion. If the order size and frequency is often, think about you ordering bread every day to your shops to be delivered. It's easier to get away with a collusion rather than seeing one big order of bread for the year. That's why the bread cartel existed. So this section is probably going to get asked. Points 1 to 6, as you see them on your page, is not sufficient to help you answer them. I'm not going to lie. Okay, so big star, some homework, go look at it. Okay, then we are going to move on to what's called the Stackelberg or the first mover advantage model. Ladies and gents, this is probably the second last section before we round off for tonight, so let's just stick it out. The Stackelberg or first mover advantage model says you generally have a monopoly in a market if you are the first to market and you get early adoption. Why? Because as you get early adoption, what happens to your marginal cost in the beginning? It goes down. Now, you've got a head start compared to your competitors. So they still need to get that benefit, and what do you know? Early adoption model. Okay, now, what I want to tell you is the following. Does a dominant firm in an oligopoly structure always stay the dominant firm? No. Because what happens over time? You start with technology A, you develop it to technology B. You have a patent for technology B for 3 years. What happens after that? Your competitors get to go straight to technology B and leapfrog you. What you'll see in your notes, and you get questions all the time that says this, firm A has 55% market share, that the dominant firm, will they stay there forever? They've got a monopoly. No, they won't. Okay, at least that's what your notes say. Now, the second way you can get asked in this type of thing is the following. Let's see if it's over here, the large firm problem. Okay, I just want to make a point here. We'll come back to that page. Just want to see where this is. As you can see, there's a lot of notes, but don't worry, we will skip over a lot of the stuff. Just trying to find these. I don't want to redraw it. There's an exact example here. Sorry guys, bear with me. I'm wasting your time. Properly wasting your time. Here we go. Okay, this is on page 18 or 19 for you. I hope it's 19. Let's have a look at it. We are talking about the Stackelberg first mover advantage model. Okay, now, what I want you to imagine is the following, ladies and gents. If I am the largest firm in a market, and my costs are also the lowest, what do you think the smaller firms competing with me can do? Do you think they can raise their price above mine to earn extra profit and catch up? No. Do you think they can drop their price by a lot to undercut me price-wise so that they can get more market share and catch up? Maybe, but what happens if I'm a low-cost producer and I can take a loss for longer than they can? I can outlast them in loss territory and I can undercut them. That's one of the economic theories. That's why when you go into different countries, they worry about, whether you're going to, I forgot the term, other economists help me out, where it's short run losses and then you spike the price up. Anyways, you get the point, don't worry. Now, that's why when it's the Stackelberg model and it's the large firm or first mover model, here's a question. Firm A, B, and C are a 10% share of the market respectively. Firm D is 70%. Firm D sets their price at $10. What will firms A, B, and C do? They will match it. Okay. Now, have a look at this. Let's take this large firm theory and we're going to move to this low-cost producer model. Dominant oligopolies price leadership. So not only do they get to charge what they want when the price is good, they can outlast when the price drops. Think of mines. Who knows what the low-cost producer mines in South Africa are? Who are they? Well, you should know. I'm going to judge you now. Okay. Anglos. Okay, let's go. Anglos is a low-cost producer, and let's say Glencore is a high-cost producer. Please don't take that. I know bugger all about these companies, so I don't know what I'm just talking nonsense here. Now let's add Anglo and Glencore together. That bold line is the total market demand curve for the product. What can we see as the price goes down? What happens to the quantity? Increases or decreases? It increases. Okay, now it goes out further to the right. Now what I want you to see is that this dotted line in the middle is the large firm share of the market, the low-cost producer Anglo. What happens if for whatever reason the price of whatever ore or commodity that they mine or produce halves? Do you think that Glencore can stay in the market? No. So that's why the dotted line gets closer to the entire market line, because the lowest cost producer will eventually become the entire market. And that's the only other thing that you need to know when it comes to the Stackelberg model and oligopoly price leadership. Then we are done. And I think, where were we? Yeah, we were. Okay. Happy with that. Cool, let's skip through a couple of sections quickly and see where we end off. Ladies and gents, we're now on to a monopoly. Okay, monopoly, they've got a protection that's a single product, there's one producer. Simple. Do you need to know all of these different functions? Yes, you do. Do you need to know it in the algebraic manipulations? No. You're not going to get given an algebraic manipulation in the question. That's probably likely. You're going to get actual numbers. And you've seen that already. Okay. So let's move on. Marginal revenue, total demand curve, exactly as you've seen before. Nothing changes. Total revenue functions. Nothing changes. Supply analysis. There's something that I haven't told you. Do all of these different types of companies in these different types of markets have well-defined supply curves? No, they don't. Can I tell you with confidence what a perfectly competitive firm is going to supply? I actually can. They can supply all they want at a single price. Okay. Can I tell you what a monopolistically competitive firm is? Yes, it's the marginal cost curve. Can I tell you what a supply situation is going to look like for an oligopoly? No ways. We don't know how that firm is going to compete with that firm, and it's going to feed back and it's going to spiral out. Same thing with monopoly. We have no idea what they're willing to supply, but we know that for an oligopoly and a monopoly, the marginal cost curve are the supply curves. I've seen 1 or 2 questions like that. Note it down. Okay. Supply analysis we've seen. Don't worry about this. As you can see, that's just the industry. So let's put a plus and an equal sign there. We've spoken about opportunity costs, accounting, economic. We just went through the situation together, so that's fine. And we spoke about this at length. The price leader determines what the price is going to be for their profit maximizing point. Just because I'm a smaller firm doesn't mean my cost is minimized, therefore profit maximized. No. Okay, but we've spoken about that. That's fine. Let's see over here, ladies and gents. We are now talking about a monopoly market. Rule number 1 is where profit is maximized. Right? Everyone happy with that? I've bored you with it 100 times. No worries. Where's my marginal cost curve? Where's my marginal revenue curve? Well played. There we go. Thank you. And what do? We take it up, hop, skip, and a jump to where the average cost is. So what do you know? That's a monopolistic profit over there. Can they continue to earn that? Yes, they can. Okay. Now, let's see. We don't need to do any of this. You must be able to work it out. That's a perfectly competitive market. We don't need to worry about that. We've spoken about this before. Does everybody understand this one thing just before I move on? You will probably get a question on this. The price is equal to the average revenue is equal to the marginal revenue for a perfectly competitive market. I can sell every unit I want at $10. If I sell 1 unit, what's the average? $10. 10 divided by 1. If I go from 0 to the first sale, how much is my marginal revenue? $10. Okay, what's the price? $10. If I sell 100 units, well, 100 times 10 divided by 100 is 10. Sell my 100th unit for an extra 10. You got it. Okay, just please make sure you know that. Okay, I'm not going to explain that fixed costs don't vary with output. You've got that. We've talked about optimal price 1,000,000 times, no problem. I'm going to repeat this for the sake of it. Oligopoly, the optimal price is at the kink of the demand curve. I've said that twice now. I'm not going to bore you. Okay. I want to talk about this, and I think this is pretty much, we've spoken about this price discrimination, so I'll cover it very quickly. I want to give you the 3 situations how we can manage the price a monopoly can charge. So ladies and gents, let's talk about Eskom. Let's say Eskom, it costs them 50 cents to make a cost per kilowatt, the cost per kilowatt that they charge us. We get charged $2 per kilowatt. Okay, I know our complex gets charged somewhere close to there, but that is an expensive price. Now, how do we get that numbered down to a fair price? We can regulate it by the government. First thing says, let's take it down to the cost of production. If we take it down to the cost of production, the 50 cents, is there a reward to the capital that was invested into the infrastructure of Eskom if we take it down to its cost? No, there isn't. Okay, so we rule out that first one, but it is profitable. But then what does the government need to do? It needs to fund. Let's speak about that funding for the second one. The second one is that we can nationalize it. Okay. Now, whatever profit that SOE makes goes straight into the state coffers, which benefits us. Okay, but here's the points, ladies and gents. Once we nationalize something and it's now ours as a country collectively, what happens if Eskom needs to raise their prices because the input costs go up? Do you think we as citizens are going to easily let the price go up? Hell no, there's going to be anarchy and tires burning, and so not an easy model in of itself. Last one says, let's meet in the middle, and let's take the average cost, that LRAC, not the marginal cost, the average cost, because that includes a return on capital that's appropriate, and let's manage it at that price. So we'll see MPRPC, that's what it means. That's those three different considerations. I've seen like one question on that. Okay. Price discrimination, and then I think we're good to go. To be honest, let's just quickly do a quick little flip through. Yep, we've talked about that. Oh, one last thing. We'll go to the last page after price discrimination, the very last page. Earlier, I talked about consumer surplus, right? On the opposite end of that is producer surplus, but I very much doubt you will get asked that. They tend to focus on consumer. Now, I gave you that example of the gym fee. You pay €2, and the extraction of that entire consumer surplus was, I charge you an €18 fee. A fixed fee, and I charge you €2 whenever you come in. Now, how did I extract that 18 from you? Price discrimination. But there's varying degrees. So let's start with the first degree of price discrimination. Let's take that Galton board example for myself. I would probably be willing to pay a little bit extra than most people in this class, if not all, are willing to pay for that thing. And everybody's got their own little thing. Some people want this card, that piece of art, some toy, it doesn't matter. Imagine the company that made that could ask you exactly what the highest price is that you're willing to pay. Ask that to everybody in the room, and then charge them that exact price. That's first degree price discrimination. Okay. Second degree price discrimination says we are going to offer you, if you buy 100 packets of sweets, we'll give you a discount. If you buy one, you're going to pay a higher price. The menu or the choice offering is yours to make. Think a lot of us are going to end up in asset management services, probably in somewhere or another. If you give an investment manager R1 billion, do you think you get a cheaper unit class or a fee than if you give them $1,000? Without a shadow of a doubt. That's exactly what that is. Second degree price discrimination. That defines our entire industry. Heck, that second bullet point is my job. Okay. The third one is when there's no economic basis, it's a demographic basis to offering a discount. I.e., you walk into a local Pick and Pay or Woolies on a Wednesday or a Thursday, and you just check everybody walking around there with their strollers. That's Pensioners' Day. There's no reason that they get a cheaper price except that it's third degree price discrimination. Elderly people get discount because we love you. Okay. Do you need to know this? Yes. Reminder, do you need to know that example that I gave you about that gym membership with the extraction? Yes. And literally, the very last one now, let's talk about how we can identify market structures, but specifically how we can know whether they are concentrated and therefore have power over the market. Okay. Ladies and gents, the first one that we're going to have a look at here is the econometric approach. Everybody knows what a beta is, right? Sensitivity, slope. Okay. Now, everybody knows as well that you need that beta or that slope coefficient to go into your elasticity number. How do you get a beta? Well, you do a regression, you get the sensitivity, Bob's your uncle. Where do regressions come from? They come from econometric approaches. Okay, That's where all your GARCH models, your time series training, blah, 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 you got it there. So that's what this says. But now, what does this tell us, ladies and gents? It says that even if I have one firm in the market, is this firm going to dominate the market and ruin it? No, because if their elasticity of demand is still extremely high, okay, then it doesn't matter that there's only one firm supplying the market. They change the price by a bit, people learn and say, no, thank you, we're cool. Keep your product. So that's the first one, econometric approach. Okay. The second one is just the summative approach, a simpler measure, adding up the total market incumbents. Will you see a question on this approach? Probably. How does it look? There are 10 firms in the market. How much of the total market share cumulatively do these top 10 firms comprise? Well, 10% each, therefore 90% each firm shares 10%. Comment. Okay, not going to be a problem. However, firm A and firm B have 40% and 30%, and then the next three firms have 10% each. Okay, that is a more concentrated market. The top 5 firms have 40, 70, 80, 90%. Okay, so the top firms have 90, top 4 firms have 90%. You got that? Okay, now let's just write this out. We have 40%, 30%, 10, 10, what's that, 70, 80, 90, and then this firm over here is 2.5%. Okay, so that over there is going to aggregate up to 90%. Now, here's the pitfall with this question, and this is often asked. What happens if these two merge into one firm? It's going to look like this. 70, 10, 10, 2.5%, 92.5%. So what you can see is this concentration ratio that we call it hardly changes, even though firm number 1 now has virtually the entire market. That's the downfall with this measure. And the very last thing for this evening is what we call the HHI measure. And this is not in your notes, unfortunately, but you get to add it in. So, how does this work? The Herschelman-Herfeldendal index, or something like that, is the following. It is the sum of the weight squared for each of the observations I through to J. Now, what this means, ladies and gents, is that you have a situation. If you take a percentage and you square it, then you can have from 0 min to 1 max. If you multiply each percentage by 100, then you go from 0 min to 1000 max. So just depending on the type of question, be careful. How do we know this? Because 100% as 1 squared, 1. What's 100 squared? 100 times 100 equals 1,000. Okay. Or is that 100,000? I've got my numbers confused, but my brain's done. 100 times 10 is 1,000. Okay, so it's 10,000. Well, there we go, recovered. Okay. Now, what this means is how you answer this is the following, and then you're done. Firm 1 has 40% market share. Firm 2 has 30% market share. Firm 3 has, I don't know, let's just make it simple. 0.3 as well. Okay. If we do this, we say, all right, 0.4, 0.3, 0.3. We square it. Okay, we add them up. 0.34. Now, what you need to do is you need to go find in your book, you need to see the point that says, if it is 0.3 and lower, it's not a problem. If it's above, it's a real problem. If it's above 0.7, you're screwed. That's a very different situation where if it looks like this. Top firm has 70% market share. That is 0.15. That is 0.15. You can see that number's a lot higher. Okay. And that there, ladies and gents, is the index. It's the exact same way as if we say, we take these numbers up, we square those. There we go. Now you can see that in 10,000 terms. And that's the last thing that you need to know for the night. You are done. I've kept you here for a very long time. Thank you for your concentration. I'll see you next week.